Calculus is an interesting subject to learn. Others find it impossible to cope with, but for some others, they might actually find themselves enjoying solving problems related to calculus. This is because bridges, cars, and buildings, technologies that you can find all around you are the living proof that calculus is an essential knowledge that one must acquire and apply in their daily life. However, one might find themselves struggling to understand a few questions.
And that's what friends are for. A friend in need is a friend indeed.
Calculus has a wide range of topics there is to learn. But fortunately for today, we're only going to discuss about differentiation.
Now, before I tell you what differentiation is, I have to explain the concept of what a derivative is. So, a derivative of a function of a real variable measures the sensitivity to change in the output value with respect to a change in its input value. So, for example, if we're looking at a derivative of a moving object with respect to its time, then we're actually looking at the object's velocity. So, we're measuring how quickly the position of the object moves as time goes on. So, what is differentiation? Differentiation is the act of computing a derivative. Now, we use differentiation in a great many deal of things. We just don't know it. Businessmen will use differentiation to calculate profit and loss in their businesses, and even architects use differentiation. In fact, the architect of this library probably used the concept of differentiation to estimate the amount of materials he needed to build it. I bet you didn't know that.
So, there are a lot of ways we can apply differentiation. But today, we are going to do it in a simpler way. So, let's see what we can find here. Interestingly, I found stone. And let's see what we can do with differentiation to calculate the rate of change of ripple of the water. The question states that a stone dropped in a pond sends out a circular ripple and the radius increases at a constant rate of 2 cm per second. How fast is the area enclosed by the ripple increasing when the radius is 6 cm? So, based on this question, we can identify a few information, which are the rate of change of the radius of the circular ripple, which is 2 cm per second, and the radius of the circular ripple, which is 6 cm. So, our goal here is to find the rate of change of the area of the circular ripple, which is dA dt, when the radius is equal to 6 cm. So, before start solving this question, we should know what is the shape of the ripple. So, obviously, the shape of the ripple is a circle, and then we should know what is the formula of the area of the circle. So, the formula of area of the circle is area is equal to pi r square. After we already know the area of the circle, which is pi r square, then we can differentiate the formula, and it will become dA over dt pi multiplied by 2r the power of 2 minus 1 dr dt. Then we calculate it, and it will become dA over dt is equal to 2 pi r dr dt. And then we insert all the information given in the question So it will become dA over dt is equal to 2 pi multiplied by 2 centimeter and multiplied by 6 centimeter per second. And the final answer will be dA over dt is equal to 75.4 centimeter square per second. Thus, the rate of change of the area enclosed by the circular ripple of water when R is equal to 6 cm is 75.4 cm square per second.
And that's how we measure the rate of change of ripple of the water.
So, you've seen our video and we've shown you how to use differentiation in your daily life.
We hope that you get knowledge and clarity
So you can use differentiation in your life too.